Okay, here we go. Adrian, I'm trying to teach, just so you know, okay?
Okay.
All right. So don't ask that question, please. All right. Okay, here we go. Here's the deal. You guys yesterday might have gotten a little confused in the beginning, halfway still confused at the end. I think most of you are getting on board. Some of you still might be confused, but I think after today, this is going to make a lot of sense because it's kind of repeating today. Here is what we talked about, normal distribution, which basically means if you have an average, half of the data is down here and the other half is over here. So normal distribution goes with this curve. It's known as the what? The bell curve. Okay. But in statistics, not everything is perfect. Okay. A bell curve is nice because half is down here and half is over here. But in this one, where did most of the data fall? On the lower side, where the lower numbers usually are, right? So there's lots of low numbers, but very, very few what? High numbers. So they call this a positive skew. This data is skewed, which means it's really not representing the real answer. We can come up with an average on this, but the average is really not a good average because there's so few big numbers. And there's a lot of little numbers, okay? So sometimes the other factors that can affect your data are skewed. So other factors can affect the skew of the data. This data, I can't do the bell curve. The bell curve is not allowed on this. We can't do it. This one is the bell curve. This is what we work on. And this one is skewed again. They call this one negative, right? Very few what? Negative. Very few small numbers down here, okay? We just can't come up with 68% and 95. We can't do it. So this is really all we work with. Now remember when I said juniors? If you go to probability and statistics, Mrs. Nelson, she's our teacher for that. She will take over with this skewed stuff. She'll tell you about this. She'll tell you about this. I'm not going to. But I just wanted to tell you, not all data is perfect. Ours will be. We're going to make ours perfect. Okay, here you go. First example is, talks about brown bears. All right, the bar graph below gives the weights of a population of female brown bears. The red curve shows how the weights are normally distributed. Okay, so there's the red curve showing the bell. Okay, about the mean. And by the way, the mean is what?
The average.
Yes, it is the average. You're right, John. And it's what? 115. So period 5 they didn't catch that. When it said mean over there, it meant 115. Approximately what percent of the female brown bears weigh between 100 and 129? First of all, looking at the bar chart, where's 100 pounds and where's 129?
The end of the bar.
Okay, this bar right here, on the left side is what weight? On the right side is what weight? 110 on the left, 119 on the right. So, I mean, that's how you have to kind of think about it. So where is 100 on the left side? Where's 129? On the right side. Okay, so basically what percent of the brown bears fall between 100 and 129? All of this. I heard somebody say 68. Why, Taylor?
One standard deviation.
Okay, this has happened all day. Every class, the first person that says the answer says 68% because you know what they're doing? They're saying the average is in the middle, and if I go one standard deviation right, one standard deviation left, I get 68.
You don't know the standard deviation is.
Exactly. You don't know the standard deviation. They didn't tell you, so you can't use the empirical rule. So you know what they say to you? They say what? Yeah, they just want you to guess. You read the table. Just read the table. Okay? We don't want to use the 6895 stuff. Okay? So let's talk. See the bears that weigh this much? 110 to 119?
Yeah.
What what percent of the bears weigh that weight? Go read it.
Like 42.
42. Okay, so we're getting 42. Now you might think 43. Who knows? Okay, it's a guess. Okay, next we want between 100 and 129. So here's 100 to 109. What percent of the bears are in here?
25.
Well, I don't think it's 25.
20.
But below 25. 24, 23.
Is that for both sides?
Yeah, and then they, yeah, between 120 and 129, 23. Okay, so there it is. So now you can say, I think from 100 to 129, what percent of the brown bears fall in there? What are you gonna do? Add them up and get what? 23 plus 23 plus 42 makes 80 what?
88.
88. Okay. We think about 88%. And that is kind of guessing. Last class we got 90, because I think we called this 24 and 24. So that we did. So 88 to 90 roughly. Okay?
89.
Look at this one. Letter A. It says what word? Yeah, they're not telling you the standard deviation. So go ahead, answer. Go get it. Raise your hand if you get the answer, and then once I get to 6 people, I'm going to pick on somebody. If you raise your hand, I'll know if you have it. Okay, 1 person feels like that. 2 people, 3 people, 4, 5, 6. Okay, we're up to 6. Ethan, what's the answer?
I said 60.
He says 60% of the bears weigh less than 120. So where's 120 on here? Well, this bar is 120 on the light end, 129 on the heavy end. So do we count this?
No.
No. So we want this bar. What's this one?
5.
Looks like 5. Did anybody count that little tiny sliver? You couldn't even see it, could you? So you didn't do it. Okay.
There's no bears.
So then it'd be 42. What?
42
It's 23
5.
plus 5. Is that his answer?
No, 70.
It would be 70, Ethan.
Oh,
Ethan, if you threw those numbers in,
Yeah.
either you punched them in wrong or you just added wrong in your head. Okay, it is 70, right? There you go. Good? Now the next problem you read, it mentions the word standard deviation. Now you can think standard deviation like we talked about yesterday. No, I don't like about it. Let's just say the standard deviation is what? 10. Okay? The second they start telling me that, then I just go, oh, this is normal distribution. I'm just going to make a picture of these brown bears. The brown bears look like this, with the average brown bear weighing what? 115, correct? Okay. Now, what's the standard deviation? 10. So if I go 10 up, 10 back, it's 125 and 105. If I go another standard deviation, it's 135 to what? 95. Okay. I can do more, but I'll just quit there. The question says, approximately what percent of the female brown bears have weights that are within what? 1.5 standard deviations. Oh, that's different. We didn't do that yesterday, did we? Okay, so 1.5, wouldn't that be from here? That's 1. That's about a half, isn't it?
Around there.
Yeah, somewhat. Okay, so let's go this way. That's 1, that's a half. Okay, the question is, half a deviation?
55.
1.5 standard deviation. People that missed yesterday, what's this People that were here, what is it called?
Sigma.
Sigma. It's a Greek letter. Sigma stands for what? Standard deviation. Okay, what is your standard deviation?
10.
So doesn't this really say 1.5 times what? 10. So how far am I moving? 15. So if I say 1.5 standard deviation, it means 15 that way, 15 that way. So you'd end up right about at 115, 15 more, 130, and 15 back, 100. So here's what it's really saying. Approximately what percent of the female bears have weights that are within 100 and 130? That's what it's really saying. So now go back up to your picture. Go up there and look. How many bears fall between 100 and 130? If you go to your picture, right here, where's 100?
There.
Right here. Where's 130? Right there. What's the percentage? What is it? No. Isn't it? Didn't we come up with this number, and this number? Yeah, we already did it. It's 88. We already did it. I did it right in the beginning with you. Now, they said, how far is 1.5? 15 this way, 15 this way. So that ended up being 100 up to 130, which gives me 88%. This is me estimating the percentages. Okay? I use my estimate numbers to come up with that answer. 88 is the answer. So you'd say, between there and there, 88%. Good? All right. Now that one was kind of weird if you ask me, because that was using some estimation skills that we didn't even talk about yesterday. The rest of this gets pretty, I think, pretty much what we talked about yesterday, but now there's more problems, okay? All right, here's a story about eels, okay? For a population of male European eels, the mean body length and one positive, one negative standard deviation is shown below. So you got 3 eels. This eel right here is the what? Average eel. So the average eel is what? 15.7. What's the symbol for average? X with what? A line over it. Okay, so the average is 15.7. This eel is 1 standard deviation bigger than the average. This eel is minus 1 standard deviation smaller. Okay, what they never told you was, what's the standard deviation? What number? Well, can we figure it out? Well, I think we can. Well, if you added the standard deviation of this number to get to that number, how do you get it? How do you get the standard deviation?
18.5
Yeah, you just subtract, don't you? Take the 18.5, subtract the average, and get, did you say 2.8?
Yes.
Okay, so that becomes what we think that's the standard deviation. But you better double check yourself. Do this one. This little eel is 1 standard deviation too small. So again, do some quick subtraction. Take your average, 15.7, take away 12.9. Is it still going to be 2.8? Yeah, it is. Okay, so now we've kind of proven to ourselves, yeah, the standard deviation is 2.8. All I really want you to do right now, make yourself a bell curve, and I'm going to ask you 3 questions. Okay? Go. Make the bell curve. Anybody help me with the next 2 numbers on the right?
21.3.
21.3. Okay. And 24 what? 1. Okay. Go backwards from the average backwards would be 12.9, then backwards would be
0.1.
10.1. Okay, then backwards again, 2.8. 7.3. Okay, yep. So did you do that? Got the numbers in, right? Okay, you know what? It's really, I think it's important that you just keep doing this. Throw the numbers in, throw the percentages in so you don't forget these. Between here and here, what percent? 68, but this would be what? 34%, 34% fall in each column. Okay. What about 2? 2 standard deviations away. What percent fall within 2? Okay, 68/90 what? 5. So what, if this is 95% of the data, you've already used up 68, 27% is left. Each column gets what? 13.5%, okay? So this is 13.5. You've used up almost all your data. What's left when you go 3 standard deviations out? How much data did you use up? 99.7. Almost all the data has been used up now. Anybody want to say it? 2.35% and 2.35. Okay. And then finally, there's so little left. The percentage that's left is 0.15. Okay, 0.15%. Okay, that's it. Now, answer the questions. Here's what I want you to tell me. This is about eels, right? So, this is how your quiz looks next week. What percent of the eels are, and here's what the question will be next week. It will say, blah, 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 blah. Okay, greater than 18.5 inches blank. Don't say it, just think it and put it in there. If you have it, raise your hand. Just wondering. Two people have it, 3 have it, 4 have it, 5 have it, 6 have it. Adrian, what's the answer?
I said 16%.
Okay, he says the answer is 16%. Adrian, just tell the class how you did it.
I just added everything from all the percentages from 18.5. I just added them together.
Okay, so basically, you know, guys, we're talking what eels are longer than 18.5. It'd be this column, this column, this column, right? Can you remember this? The last column, the last 2 columns, this and this add up to what? 2.5%. So just in my mind, I never really add this to this. I just say this and this is 2.5 plus 13.5 is
16.
He got it. It is 16.5. Everybody good with that? Okay. Nobody has questions? Okay, now do it again. What percent of the eels are, let's do this one, between, let's go 12.9 inches all the way to 21.3 inches, okay? Between here and here equals what percent? Raise your hand when you have it. One person. 3 people have it. 4, 5, 6. Come on, some more people have to raise their hand. Different people. Okay. All right, here we go. 12 what? 12.9 to 21.3. So we go here, we go 12.9. Oh, right here. To what? 21.3 right here. So basically I want the percentage of eels that fall in these 3 columns, okay? Faith, what was it?
I got 81.
She gets 81.5, is she right?
Yeah.
What's this plus this?
68.
You can do that quick. 68 plus 13.5. Did she get it right? Yeah, she got it right. Okay, last question. Here you go. Okay, now I want this. I'm going to tell you right now the population of eels in this body of water is 4,000 eels in this body of water. Okay, here's my question. How many of these eels are between 12.9 and 21.0? How many of the 4,000? Okay, I got 1, I got 2, I got 3, I got 4, I got 5 people, 6. These are the questions you will be asked, okay? Aaron, how many?
3,260.
You said 3,260? Okay, Aaron says 3,260 of the 4,000 eels will be between here and here. How'd you know? How'd you figure that out?
I'll multiply 4,000 times the percent.
Times the percentage. Okay, so more or less, when you guys want a percentage of any number, I'll call it the population. Okay, when you want a percentage of any number, what does of mean?
Multiply.
It means what?
Multiply.
Multiply. It's meant multiplication for like, since you were probably in 7th grade when they told you. The population is 4,000 eels, and you want what percent? 81.5. When you type that in your calculator, how do you type it in?
81.5%.
No.
815.
Yeah, 0.815. The secret is move the decimal where?
Three, 2 places.
To the left. To the left. Okay, that times that. Would you help me out, guys? Is Aaron right? Yeah, he's right. Okay, good. You got it, Aaron. Good job. Now, the next problems, they're all kind of the same. I just want to see you do it without any help, okay? This one. Do it. A, B. Get me some answers. Draw the curve. Draw the curve. Hopefully I didn't make mistakes. I kept adding 2.5 or subtracting 2.5. I think my number's right. Okay, all right. I'm just going to throw some percentages in. I just want to know what they are. 13.5, 13.5, 2 and a 235, I guess. First question is, what percent of the American males are between 67 and 74.5 inches tall? Well, I drew my green lines to show you where the boundary lines are. So what did you do? You just added them. What'd you get? 81.5, isn't it? Yeah, 34. Plus 13.5 is 81.5. Okay. Not too hard, right? Okay. Continue. Now the next question says, in a group of 2,000 males, adult American males, about how many of them would you expect to be taller than what? 6 feet. Well, the thing is, your table up there, your bell curve, is in inches. So what is 6 feet?
72.
72 inches. So go back up. Where's 72? Right here. 72. Greater, taller than 6 feet. That'd be basically this section, and this section. Altogether, 16%, right? So you got 16% of the American adults taller than 6 feet tall. But that wasn't the question. The question is, how many of the 2,000 would you expect to be 6 feet or better? Well, would it be this times what? That many people in the study? Of course, you're not going to punch in 16, I hope. You're going to punch in what? 0.16. What's the answer? 320 adults. Adult male. Yep. And American, by the way. Because if you said Chinese, the Chinese population, 6 feet and taller, I don't think we're talking 16%. Okay. All right. Okay. You do not have a worksheet today. You have a book assignment. It is 11.6. It is whatever the calendar says. Okay. Do you feel like this made a lot more sense today? Than yesterday? And guess what? It's pretty much the same stuff I talked about yesterday. It was just so brand new to you yesterday. That's why it was like, I don't quite get what he's saying. But I hope I took it slow enough and it sunk in. Okay? Tomorrow, it's one thing. We are just going to calculate standard deviation. We're actually going to come up with it ourselves. All right. Hey, Isaac, can you get the light? Thank you. Yeah, you can get them both.
Can I go to the office?